go. There are infinite discontinuities at 1 and 3. Infinite discontinuities, vertical asymptotes. Infinite discontinuities resulting from infinite form, number over 0. All good things. Number 12, A is a yes, B is a yes, C is a no, D is a no. Number 20. At x equals 2, the function is discontinuous, but it is a removable discontinuity. If you make f of 2 equal 1, all of your problems would be solved. You can make a, what's it called? A continuous extension. If you made a continuous extension, a piecewise function with f of 2 equal to, sorry, the cursor's on it, 1, you would be just fine. Number 24. The function is not continuous for any point not in the domain, but also not at 1 or 2. 1 is removable. Sorry, not removable. Sorry. At x equals 1, it's not removable. You have the limits not existing. And then 2 is removable. You could assign f of 2 to equal 1, and you'd be great. Hey, that's the same thing as that one. That's ironic. Number 28. You guys remember how to do these limits? No? Oh, you party poopers. Sine of u over u. Limit as u goes to 0, sine of u over u is 1, but I need the u's to match. So therefore, all I need to do is multiply by 1 created. 4 over 4, pull the 1, 4 out. Now I have sine of u over u. That's 1 minus 4. Or you can memorize a new rule that sine of ax over x as x goes to 0 will always be just whatever a is. You can memorize that. Multiply by 4 over 4. Because we need sine of u over u. So when you multiply by a 4, we have to balance it. So 4 up top and we do a 4 down bottom. And that's just a coefficient that we can pull out. Is that cool? So if we fill the hole with 4, it'd be great. And there would be our continuous extension. Number 42, you can have some creativity. But there's one option that would fulfill all of its conditions. We have 1, 2, 3, 1, 2, 3. Number 48, a equals 3. And then I think that's the last even, right? All right, do we have any questions on homework? Ooh, Patricia has one.
Why is it a no? Because it's a one-sided limit.
12C, why is it a no? It's a one-sided limit. Hold on. Any other questions besides number 12?
No.
Number 9? Number 7. Okay, let's start with number 12 and work our way backwards. So, hey guys, if you're bored, why don't you just get on your AP Classroom and start playing with multiple choice questions. Now, that opens up a really dangerous door. I realize that, but at least you would be being productive. But if I see phones just randomly out at all given times when we're going over notes, etc., I will assume you are not being productive. But at this point in time, if you have absolutely no homework questions, you could be playing on your multiple choice on AP Classroom. Okay, number 12, Patricia, sorry, which letter?
C. Never mind now. I can understand.
Are you sure?
Yeah, because it says equals f of 1.
Oh, right. So the limit does exist, but it doesn't equal f of 1. Got it. Yeah, good. We were going backwards to number 9. Okay. Number 9 is the nasty piece. There we go. Not the piecewise. Yeah, y equals e to the 1 over x, and you're supposed to be thinking about continuity. So the only place this would be discontinuous is x equals 0. However, when you plug in x equals 0, 1 over 0, because exponential functions are good for all points in their domain. Well, okay, 1 over 0 doesn't exist. But 1 over 0 is infinite, right, guys? Mm-hmm. Infinite, that would be a non-removable discontinuity because I can't fill the hole. E to the 1 over... Yeah, it'd be infinite because the limit would be infinity as I approach x equals 0. There must be a vertical asymptote there. Does that kind of make sense here? Yeah. And then number 7. At Ooh, this is a great one because CalcBC had to do this one. Absolute value of x over x, guys. How do we rewrite that as a piecewise function? Oh, why is my computer not working? Yeah, we have to think about less than 0 and greater than 0 because we're thinking about absolute value and when it acts differently. It acts differently for positive numbers than for negative numbers. There is a discontinuity at x equals 0 because I can't have 0 over 0. However, to consider what type of discontinuity, because isn't 0 over 0 normally removable? Right? It's always removable. It's a whole. It's no big deal. But in this one, hold on, it's truly a piecewise function. And so remember, for negatives, now some of you might need to write this in wording because we're going to have to deal with absolute values this year. And so it might be a good thing for you guys to finally get them down. For negatives, remember, absolute value switches the sign. So if I put in a negative, absolute value makes it opposite. Negative and negative would be a positive. But if I have positive values, now I'm not including 0, because 0 is not included in the domain. X is not allowed to equal 0, because 0 over 0 does not exist. As far as a value. The limit could still exist, but as a value, that's undefined. For positive numbers, x stays the same. So if I write out what the absolute value actually is, it's a piecewise function. Well, hold on. Yes, I can reduce 0 over 0, but what would happen when I reduce this expression? It would become a negative 1. And how about this expression? It would become a positive 1. Yes, you can reduce out the whole, but the problem is I have a non-removable discontinuity. They both have wholes, but their limit does not agree. So even though, yes, it's a whole, a 0 over 0, we do keep going. When you keep going, you get a piecewise function where you have a non-removable discontinuity as two pieces come in towards their wholes, but towards different locations. Does that kind of make sense? Just because it's 0 over 0 does not necessarily mean it's removable. You have to still watch out for piecewise functions, which can be hidden in absolute value notation. Kind of make sense? Okay, we went over 7 and 9 and 12. Anything else you guys want me to go look at in homework? Going once, going twice. 31. 31 is asking for you to explain why the function is continuous. And it gives us the function, oh, sorry, up here. 1 over the square root, though, right?
No.
Oh, 1 over x minus 3. Oh. Where is that function discontinuous?
X equals 3.
Mm-hmm. So, wait, it's wrong? This should have been everyone's question. Why is the given function continuous when the function is discontinuous at x equals 3? X equals 3 is not within its domain. So in this textbook's definition of continuous, it's continuous at every point in its domain or checking for continuity for points in its domain. So x cannot equal 3. Why? It's natural. The denominator can't equal 0. So is there a discontinuity at x equals 3? Yes, but it's not in its domain, so that's not what's being considered in this question. That's the hard part.
How would you know that it's continuous?
Well, it's getting used to our textbook, and to some extent there was, oh, where is it? Probably didn't cover it because I think more like the AP and less like a textbook. Here we go. According to the definition, because if I were you, I would have been totally confused. And so where should that confusion have led you? I gave you a different textbook on purpose this year. That confusion should have led you to, wait, what are they saying, right? Because it was super obvious. X can't equal 3. You guys were totally right. So why are they saying this? And they're giving us that problem on purpose to confuse us. Well, go look in the section and say, what do you mean when you say continuous? Hey, is this a life lesson? No. Think about it. Come on. This is a super important life lesson, especially given this time, this context, this age. What am I referring to? when something doesn't make sense or something someone is saying doesn't make sense, if you disagree strongly with someone, what is the very first thing that you should try to do? No, but that's what our culture does, right? Or blast them for thinking differently, right? Because to be honest, our culture doesn't even start with convincing them that you're right. It's like, no, make fun of, mock, and belittle because you think differently than I do. So, before even convincing, and definitely in lieu of the whole belittling thing, shouldn't you try to make sure that at least your vocab is similar? What do they mean by what they say? And why do they mean it? Trying to understand where they're coming from. True? There's a whole TED Talk on, anyway, it's really interesting. Maybe I'll show it to you someday. About, and it's actually a math guy. Ooh, I totally should. Anyway, we'll come back to it. There's a whole TED Talk on that, which is really interesting. As far as, nope, I'm going to butcher it if I try to say it. I'll get you the phrase, though. It's a good one. So, long story short, they said, where is the function continuous? You're like, no, it's not. I know it's not. I would bet my life it's not. But pause and look in this textbook. When they said that wording, what do they mean by a continuous function? A continuous function is one that is continuous at every point of its... Ooh! Hence why it's continuous. It's continuous for all values x not equal to 3, and x not equal to 3 is not in its... x equal to 3 is not in its domain. Perfect. According to you, yes, it is continuous. Struggle, right? Okay. So remember, we're in a different book. We have to keep an eye open for what they're trying to say. Anything else? Great question, Lainey. Thanks for bringing it up. Anything else in homework? Yeah. 48. Find a value A, which is perfect. This is exactly what Calc AB saw for the first time today. Finding a value that makes it continuous. Finding a value that makes it continuous. Now, guys, what's the shortcut whenever you see something like this? What's the shortcut that pretty much will almost always work? We couldn't find a counterexample yesterday, and no one came to me with a counterexample. Set the equations equal to each other at x equals the separator, right? So plug into the top. 2 times 2 plus 3. What are we doing when we plug into the top? We're technically finding f of 2, but we're also finding what else? When we plug in 2 times 2 plus 3. When we plug in 2 times 2 plus 3, yes, we're doing f of 2 because of the or equal to. But aren't we technically also doing the limit as x approaches 2 from below? We're doing this and this when we plug into that top piece. And then why are we going to plug into the bottom piece? And why am I going to put a big old fat equals? I need this to match with this to match with this to be the definition of continuous. So then I can go ahead and do a quick, that's 7, and that's 2a plus 1. That would be 6, and 6 divided by 2. We got 3, right, guys? Yes. But do you see how the math of plugging in, setting equal to was fulfilling the definition of continuous? It was super similar. I don't know if it was the exact example. It might have been. I don't remember. Do you know like it?
Yeah, I just did my multiplication wrong, but I know.
Struggle. It's okay. Calc AB in their summer review quiz, I had so many kids do 3 times 3 is 6. I was like, you've been there. You've done that. But it's a struggle. All right, anything else in homework? Going once, going twice, and sold. Section 2.4, tangent lines and sensitivity. We could do a life lesson with that right now. Sensitivity. Beep. Beep. Rate of change. We're coming back. We were there in section 2.1. We're back in section 2.4, but just for a little bit. Tangents, tangent lines, those are easy. They were in our summer review packet. They're so easy. And then sensitivity, is it a good thing or a bad thing? Or maybe it's both. Maybe it's a blessing and a curse. Maybe without it you're a jerk, and with it you're a crybaby. I already told you I'm a sensitive person. Calm down. Take a breath. But that's the pendulum swing, and that's the judgmental way of looking at it, right? You're not very sensitive. You must be a... You're too sensitive. You must be a Don't we go to extremes way too easily? We go to judging way too easily, especially when it's something that's hurt us in the past, whether or not it's the person's fault that's right in front of us. Struggle! I feel like you're looking back though, right? Average rate versus instantaneous rate. Why the heck am I bringing that up? Because average rate is the slope of a secant line, whereas instantaneous rate is slope of a tangent line. And what section are we in? Tangents. Oh. Maybe we've gone off on a few, but maybe they're at least somewhat related. Calculus, the one time you can make some jokes about going off on tangents. And actually have a meaning. You guys got it? Can I scroll down? No. Oh. All right, then let me go ahead and do a full screen of a whole page. How about that? Doop. Because all of those are the same, you guys know the AP can refer to a derivative in so many different ways. Yeah? The slope at, the slope of the tangent, the instantaneous, the limit as h goes to 0 of. Ooh. And we even know, aren't there different variations on number 4? With the definition of the derivative last year, we saw alternate forms. True? Over x minus a, because that's the one that looks different, right? Something is a bad idea. We put a quick little extra. Yes, we could have x instead of a, but that wouldn't be at a, so I guess that's inappropriate. We could have delta x instead of h, but the one I was thinking of a little bit more was the limit as x approaches a, because it looks so different, of f of x minus f of a. Over x minus a. I would throw that one in too. It's technically underneath number 4, but alright, now it's time for us to get all back on the same track. So my AP classroom ers, aka using your phoners, stop. We got it? Okay, now I just thought this was an interesting piece of information. So, mathematician. Pierre de, who's in French? Go ahead. What's his name?
Pierre de format.
Not in French. Who's in French? Someone's in.
Pierre de Fermat.
Even worse.
Fermat.
Fermat, yeah. Fermat's theorem, Fermat's last theorem, it's one of the $1 million problems that was interesting. Anyway, look up the $1 million problem. But most people that solve the $1 million problems don't take the $1 million because they're like, no, I did it for the pure love of the field. Anyway, Fermat was a lawyer who worked for the regional parliament in Toulouse, France. He invented his method of tangents. What? Tangents. In 1629, he solved the problem of finding the cone of greatest volume that can be formed by cutting a sector out of the circle and then folding the circle to join the cut edges. What? Calculus came from geometry almost every time? Yes. But what I thought was interesting was about the word normal. So first of all, Fermat had a deal, or came up with the whole idea of tangents when talking about a cone of greatest volume. Who would have done that? But also, what do you guys learn about the word normal? Latin. English. Yeah.
English.
I'm guessing English instead of England, but we can double check.
That's probably English.
Fool.
Has anyone ever wondered why a normal line, an orthogonal line, is called normal perpendicular? Maybe you guys haven't seen it a lot in physics, you should see it. And in CalcBC, we saw it once or twice, didn't we? Finding the normal line. Yeah. And I had to be like, oh, it's perpendicular. Because of Latin. Go figure. Maybe we should all go to classical academies and learn Latin. It would help with science. It would help with math. Okay, sensitivity. I'm not talking a lot about tangent lines because you guys have a forever card, so I apologize. If you want me to do y minus y1 equals n times x minus x1, hey, the n is the derivative. We could, just not wanting to waste your time. While reminding you that the forevers are important and we cannot let them go. And I probably should have had forever endeavor quiz tomorrow on the old forevers and the new endeavor. Although the new endeavor doesn't exactly apply to what we're doing right now, does it? The polar and parametric. Lame sauce. So I don't know. I haven't totally decided. I think I might not do forever quizzes before every test, even though I probably should. Although some of you might be like, but I kind of liked the 3 points thing. And some of you are like, well, I never did what I was supposed to actually have them help my grade. They usually hurt my grade instead. Struggle. But we do have to have at least a few forever quizzes this semester. We get a lot of endeavors. I think we get about 30 of them next semester. We will get endeavors, but the forevers are still important. But for right now, we just focus on the task at hand. Sensitivity. What is it and why do we have to deal with it? How one variable responds to small changes in another variable. Apply that to life as you would desire. But let's come back. How one variable, one quantity, responds to small changes, incremental changes in another variable. And the one example that I think is most interesting, and I think our book focuses on most, is sensitivity to medicine and dosages. Sensitivity to medicine and dosages. Now, it is in an example, and yet it's information that's going to be key for you guys being able to think through and solve through sensitivity tonight. And remember, technically, once again, all of this is before a derivative has been taught. So this, for the application of sensitivity to medicine, which P.S. there's a whole class in college called business calculus, how calculus is applied to business. There's a calculus for science majors or for nursing majors, etc. How calculus is applied to the sciences and especially the medical field. This is one example, sensitivity to medicine. Sensitivity can be defined as the limit as delta D approaches 0 of change in T over delta D. Wait a minute, hold on. Couldn't this be like a definition of a derivative, guys? For you guys, where you are at, knowing what derivatives are, doesn't this look like an instantaneous rate? So who's what and what's who? When we're normally doing this, isn't it the limit as change in x goes to 0 of change in y over change in x? F of x plus h minus f of x. That's a change in y over change in x. So who's what? Isn't t my y variable? Or my dependent bar? And isn't d my dependent bar? I said that backwards. I apologize. Isn't t my dependent and d my independent? But what do you guys see down here below when you see the function that's given to you in this problem? Isn't it t of d like we would expect based on how this was set up? So t is my y, d is my x. My little pen is in the way. Shoop. They give me a function for, okay, what's going on? A patient entering the hospital with a temperature of 102 degrees Fahrenheit is given medicine to lower the temperature as a function of the dosage. Oh, D is dosage. That's helpful. The dosage is measured in milligrams. The patient's temperature will be. So what's actually getting smaller and smaller is the dosage. As the dosage goes to 0, what is the change in temperature? Basically, very, very small changes in the dosage. How would it react or how would it affect the temperature of the patient?
Higher the dosage, like the less of an effect will have.
That's not necessarily the context of the problem. This is more of a warning against overdosing and trying to figure out for a given patient. I mean, this isn't necessarily, but like there are a lot of different factors that would affect what dosage they could give a patient. Like it could be body weight, it could be like their health record, it could be how high the temperature is or what type of medicine. Like, there are a lot of different factors. But sensitivity is the idea we don't want to give them more than they actually need, right? So in this one, how will the patient's temperature be affected and how quickly do we need this to come down? 102 isn't drastic, but if it was like 100 and, I don't know, 8, 110, like this is, what is this person going to live kind of thing, right? Get it down fast, living in ice. But find and interpret the sensitivity of the patient's temperature to the medicine dosage when D equals 1. So when the dosage is 1, which this can change, dosage is 1, dosage is 5, dosage is 10, what or how sensitive will the fever be, will the person be as far as its temperature? So what do we actually do? If this is a derivative, if we have a definition of derivative, we can say the limit as h goes to 0 of f of a plus h minus f of a all over h. How do we apply that to this problem if we were doing it the non-derivative way, the limit way? Couldn't we plug in limit as delta d goes to 0 of t of, if I'm doing such that 1 isn't 1 by a, right? Like f prime of a. So 1 is the dosage that I'm considering at. I have 1 plus, I could do h, but I could do delta d because that's technically how they showed it. Minus t of 1 all over delta d. Can I do it like that? Or didn't we just write the alternate form of this? Didn't we technically do this exact same thing? But instead saying, hey, as d goes to 1, what is my t of d minus t of 1 all over d minus 1? Which one looks easier, the top one or the bottom one? Yeah, I think so too. I think so too. So my function for temperature based on dosage in this case is 99 plus 3 over 1 plus d minus t of 1 1 plus 1 would be 2, 3 halves, that'd be 99 plus 3 halves. I don't like that. All over d minus 1. You're welcome, some of you guys that realize under summer review quiz that you're really bad at complex fractions because we have one you need to simplify. If we're doing this without a derivative. So how do we simplify this big old complex fraction?
Multiply the 2 times 1 plus d.
Yep. And my summer review people who did their corrections carefully, we remembered or we realized this entire thing has to distribute to both, right? And inside both we have multiple terms too. Well, that's kind of nasty. Unless you realize that 99 minus 99 is just going to go away. That makes life a little bit easier. We have the limit as d approaches 1 of 6, right? 3 times 2 and the 1 plus d's cancel. Minus, the 2's reduce. 3 times 1 plus d, don't kill a seal, distribute that negative, my sillies. 6 minus 3 is going to be 3 minus 3d. You guys agree? 6 minus 3 is minus 3d. That distribute all over. You guys see how this d minus 1 is going to reduce with the top and a 3 is going to be left? My final answer would be plug it in 3/4. Ooh, what are my units though? Because I just did an instantaneous rate.
Milligrams per.
Oh, did I have it switched? Yeah, I didn't actually do the work, did I, Lawrence? I was being a lazy bum. Which would make more sense because you're hoping that the temperature is going down, not going up. Right now we have it increasing instead of decreasing. Thank you, thank you. Not milligrams per. Isn't it delta T over delta D? So milligrams would be in the denominator, wouldn't it? What would be in the numerator would be degrees Fahrenheit. So what does this actually mean? When the dosage of the medicine is 1 milligram, when the dosage of medicine is 1 milligram, what's going on with the patient's temperature? Yeah, it decreases by 3/4 degree Fahrenheit per milligram. just do? Delta T over delta D. Mathematically speaking, you guys given your calculus background. Nope, that's switched. That's what we were trying to do first of all with milligrams per degree Fahrenheit. It would be dt over dd, right guys? Isn't that what we just did? That's the definition of derivative. So couldn't we have just done t prime of such that d equals 1? So working our way backwards, how do we take this derivative?
So it's 1 plus d times 0.
Couldn't we have brought down, that's 0, couldn't we have brought down the negative 1? And couldn't we have gotten negative 3 all over 1 plus d squared? And what was my dosage? Okay, look. Do you know derivatives? Oh! Can you use derivatives on your homework? Yes, I'm not going to stop you from using derivatives. However, is it good to be able to recognize the definition of derivative and be able to apply it to what it would look like if you did see it in a context of a problem like an AP problem where they're trying to make it look like a limit, but it is a derivative? Yes. We could have gotten to negative 3/4 a couple different ways. But long story short, what is sensitivity? They're trying to measure the rate of change of, in this case, temperature with respect to dosage, but you're trying to figure out the rate of change of one quantity with respect to another quantity as the changes are very small incremental, and that's kind of where we have the delta D going to 0. We're having those little baby changes. Kind of like the epsilon delta definition of limits. Let's not go there. That doesn't sound fun. Guys, we have homework number 6 on section 2.4, but let's peek at it real fast. Does anybody have it? Oh, the bell's about to ring. If you guys check out homework, it's really not that crazy or that big, per se. You are allowed to use derivatives, but if it says average rate, is there any using derivatives for that? Nope. You better do delta y over delta x. Have fun with the sensitivity. Come tomorrow if you have any questions. And maybe play with your sample multiple choice on AP Classroom.